Now, we got a project week 6. You got your exam next week. Your exam, we've already wrapped up what you need for the exam as far as topic-wise. I didn't include that much on it because there's no need to, really. I mean, you guys are doing the quizzes, you're staying current with the topics. The exam is just extensions of those things, really. It makes you go online, look up some stuff, learn some new terms. What we're going to be doing today is actually probably most likely going to stretch into Monday, I would imagine. Actually, your project for week 6, it would help you to do it before the exam. I don't think so. No. It's really straightforward. The project is wicked straightforward. Short and sweet. Short and sweet. I've often thought about making it a homework assignment. I'm like, it's a good project. It's a nice break for you guys. It's a nice project. Quick. But I don't think it would help you to do the exam at all. I'm not sure. The idea is it reiterates what confidence is. And I like collecting the data as a class, but there's no need to rush and get it done before the exam. I don't think it's going to help you that much. So what we're about to embark upon is what's called hypothesis testing. This is the second part of the course. There's 2 parts of this course. The first part is confidence intervals, which we've kind of, I think we understand it pretty well now. But there are also things called one-sided confidence intervals versus two-sided. So if you think about confidence intervals right now, they're two-sided. We say we are 95% confident that something is at least this, but no more than this. With 2 sides on, low and an upper bound. Sometimes, though, it's nice to know not if there's a lower or upper bound, but say if a medicine is working. You know, like I said, I wiped out yesterday and crashed on the ground and hit my shoulder, and I'm old, so it takes me a while to heal. So I take Advil for it. It's nice to know at least how much time I'm going to get from relief from an Advil, or from, I think I took 4 this morning, which I'm pretty sure is bad for you. But how much time at least, not at least and at most, but at least. So we create these things called one-sided confidence intervals. But nobody teaches those. That's okay. That's okay, because they don't have to. What they do instead is they do one-sided confidence intervals in context, which is called hypothesis testing. So what I wanted to start today with, first of all, I want to start, anybody have any questions before we get into this? You good to go? Oh, please, Renee, yes?
So what's the other limit? P?
The other limit.
Like...
Oh, so you've got a low point and it goes off to infinity, essentially.
Oh, okay.
And you've got a high point and it goes down to negative infinity, essentially. Okay. And we'll see all those today. That's part of what I just gave you, is some graphics that include that. Because it's, in a lot of ways, hypothesis testing, depending on who you talk to, first of all, it's ubiquitous. It's all over research. How many of you guys, I think you just mentioned it, a p-value? Have you guys that have read research, have ever seen a p-value in research? A couple of you, a few of you, yeah, a few of you. Those p-values are directly tied to hypothesis tests, and that's what we're going to start learning about today, or what p-values are. The reason this section exists, I invented this. Most textbooks will just leap right into start to doing their own test, collecting data, crunching tests, getting test statistics, doing p-values. Great stuff, all good. But I discovered after years and years of doing this that students were getting hung up on what these p-values were. They were misinterpreting them, which is totally understandable because they're not inherently obvious when you first experience them. I very often heard them reflected incorrectly. Like they'll say the p-value is this, and I'm like, no, it's actually this. Well, what's the difference? I'm like, ah. And I started to learn over time that maybe the idea of a p-value needs its own little lesson. So that's what this section is. It's a lesson on p-values. And an introduction, I call it an introduction to hypothesis testing. And we'll talk about all that as we go through today. Yeah, Renee, go ahead.
No, I was just, yeah.
Exactly. This is kind of a, me and Max were building a Lego windmill last night. And he was getting frustrated because there was a gear, I swear to God this is connected, there was a gear that was coming up from the bottom of the engine, and I had to turn it at right angles to turn the windmill. So that there's a shaft coming up, just like a car. There's a shaft going to your front wheels that you have to split at 90 degrees to turn your wheels. And he was getting frustrated, he's like, Daddy, it's not reaching, it's not reaching. So I took a little tiny shim, popped the gear off, put the shim on, popped the gear back on. He's like, oh, now it works. This is like that shim between confidence intervals and hypothesis testing. It will make it make more sense when you actually get to hypothesis testing, or we're actually doing the tests for ourselves. This will plug the gap as to what those magical things called p-values are. They're really decision engines. It tells us kind of what to do, what to believe, what we should believe. And this is just a lesson devoted to that. But let's take it back.
I think there are just too many damn p's in statistics.
Well, I agree with that. No, this is true. Tim, I want to mention that in about 30 minutes. There's little p, which is what? Population proportion. There's little p hat, which is your sample proportion. There's little p in the binomial distribution, which technically is the same as little p in the population, but it's a probability, right? There's the little p you put outside the parentheses, which is just shorthand for the word probability. Now there's a p-value. There's a p-bar later on, which I'll try to hide from you guys if I can, because you don't really need to memorize it. I mean, you're right, Tim. There are too many damn p's. There's plenty of other letters in the alphabet. I made one up in your last exam. I made up one called C for the Clash, because I was listening to the Clash when I was doing some statistics. But there are other letters. Let's start using them. But we don't. We're stuck with P. Well, I mean, probability, it doesn't make sense. But it can get confused, too, with other things. So, anyway, take a look at some of these. Take a look at some of these studies. I just pulled these off of, I went to Google, and I basically Googled studies show. And it's amazing what you get when you Google studies show. This one, I like this one. Diet may trigger adverse behavior in children. I find that interesting. I remember when I was in high school, ADHD was just starting to become recognized as a syndrome. I was diagnosed hyperactive when I was, no surprise, right? When I was like 5, hyperactive. And that hyperactive is now what is now called ADHD, the H in ADD. And I would watch my friends go down who were diagnosed with ADHD, and they would take their medicine and then follow with a can of Mountain Dew. I'm like, you know, okay, I get it. I get it, but maybe we're working against the medicine, maybe.
Well, no, because stimulants in kids actually is a reverse effect.
At the proper dosage.
Well, even sometimes your dosage with your medicine is too less and they felt that they needed.
Yes, but I don't think a doctor's going to give them a pill and say, you know what, chase it with Mountain Dew to get the dosage right.
Well, yeah,
No.
but I'm just saying.
And no doctor's going to say, go drink a Mountain Dew after you take the pill. They're going to adjust the dosage. That's the point. But how can you adjust the dosage? How can you adjust the dosage on the medicine if you're screwing with the stimulants by adding more to the system and the doctor doesn't know you're doing it? That's my point.
Okay.
I totally get what you're saying. No, when I learned about Ritalин's a stimulant, I'm like, wait a minute, time out. How can a stimulant work for an ADHD child? Because that's the way it works. I mean, that's the way it works physiologically. Well, that's interesting. You take an upper, but it acts essentially as a focuser. Not as a downer, but it acts as a focuser, which I think is interesting. But then I see somebody drinking a can of Mountain Dew afterwards, I'm like, wait a minute, now you're taking too much stimulant. And well, yeah.
Depends on the kid.
It does. I didn't say it didn't. But in general, it is. You're dialing the dosage in, and then you're screwing with the dosage by self-medicating with something else. Yeah, Kate.
Just to blow your mind real quick. Okay, so with being a hyperactive kid or having ADHD,
Yeah.
it's not that your brain is hyperactive. The brain is actually hypoactive, and it's not active enough, and the brain gets bored. And so, as you can't focus on one thing because it's bored, and so it moves on from one thing to another to try to stimulate itself.
But that's not in general. You can hyper-focus when you're ADHD. I'm just finished reading a book about it. It's called Driven to Distraction. And part of the ADHD mystery is the fact that ADHD students can actually rule everything else out and hyper-focus from time to time. And that's what the idea of the stimulant is supposed to do. It's supposed, think of it like this. And this is going to be kind of a weird analogy because you guys are so young. But think about the telephone operators that you used to see, switchboard operators, lady with the cords. He'll make a phone call. Who are you calling? Okay, click, plug, plug. And the idea was that the operator's job, there used to be when you dialed 0, there was an operator, and they would actually connect the call. This is going way back now. The idea of an ADHD kid is that they're doing this. There's so much going on that they lose focus on what they need to focus on. And that's where the stimulant comes in, which is weird. You'd think a stimulant would have the opposite effect, but it doesn't. It actually has a focusing effect.
It's called tweaking.
Okay, whatever it's called.
Overconcentration on menial tasks is one of the biggest symptoms of meth use. Is overconcentration on stupid.
Well, and meth is again as a stimulant, just like Ritalin or just like Adderall. But that's the idea is the medicine is supposed to calm down the operator and allow you to focus expressly on one thing. But the point is, the whole point of this discussion is that it's amazing how this gets ignored. I mean, one of the first things that should be asked is, what are you eating? Red food dye was what did it to me. Red food dye sent me through the roof. So as soon as I figured that out, I was good to go. I was good to go. What's that?
Are you still eating red food dye?
No. Strawberry ice cream. That was essentially what the... Well, that's confirmation bias. Be careful. Are you still taking red food dye? Confirmation bias if you're seeing or not seeing the... There's other things as well, but that was for me when I was 6. Now I've changed it in the past 35 years. It's no longer exactly the same as it was. But the idea is studies show. What study?
Cycle.
What study? What did they do? What did they do to study this?
Testing rats.
Well, I hope not. They immediately crossed it over to children. How would you test to see if diet triggers adverse behavior? Go ahead, Kate, describe me a study for me.
They have a kid and they probably grab
A kid?
together a bunch of kids.
Good, I like that
And
better.
they ask the parent, you know, what are they eating? And if it's pizza this, that, you know, list off what they're eating.
Okay.
They're gonna go, okay, so for 1 month or whatever their trial is, they're not gonna be eating any of that, they're gonna eat this. And they're gonna give a standard, probably.
Now, I love this very much. So a bunch of kids. Let's give it a number, say 200 kids, which is actually probably enough for a study like this. Good, very nice, very nice. Come back to that. Do we do that to all 200 kids, do you think?
No.
We could do a baseline,
But you have no control if you do it to all of them.
but that's what I'm saying. We could do a baseline, then the experiment, measure again, and then let them revert back to the baseline and see. What Lauren just mentioned is a word called a control. We'll come back to that if you haven't heard it before. I love that word. If you can't do a control though, suppose your sample's so tiny you can't afford to split them into two groups, you don't want to sacrifice the power. You could measure them once. And now when I say measure, I'm using this word pretty cavalierly. How would you measure adverse behavior? Well, good, but even how? How?
The 1 to 5.
How would you collect it? Like think of a question or a measurement you would take. And go ahead.
Well, there's a whole big list of it. Does he sit in his desk? Does he walk like a motor driven? Does
Good.
he pay attention? Does he
If you
lose
needed
things?
These sounds like the scale just reading that
That's a
book.
lot of those kids.
Yeah, right? So you've got, there's an inventory checklist. I believe Utah, the Utah inventory is one of them. There's a number of them. There's a checklist. Yes, no. Do they exhibit this behavior, this behavior, this behavior, this behavior, this
Never
behavior?
often celebrating occasion.
Never, often, seldom, occasionally, or Likert scale it. Perfect. Look for trends. Then institute the experimental effect. Then measure them again. See if there's any change. Then if you want, let them go back. That's called an ABA study, where you let them measure them at the beginning, institute some kind of a protocol, measure them a second time, that's the B, and then take the protocol away and let it go back to A and see if there's a version back to the previous. Any potential problems with that? Renee, go ahead.
It's qualitative and continuous data.
The problem is you're using continuous methods on qualitative data, which can be an issue. Thank you very much. Michael, go.
Trying to get the people to come back 3 times?
That is a huge one. Non-response. Non-response, especially over a long study. I just watched part of my friend John Liccardo. I don't know if you guys know John Liccardo. He's in the HHP department here. He gave this talk about introverts in the classroom, which I'm sure I exhaust after watching his presentation. It's interesting. He said that there was a study done at Harvard to identify characteristics in infants, in babies, that would then predict introverted versus extroverted behavior later in life. And you know what it was? This is fascinating to me.
I put that?
Crybabies. When you stimulate a baby with like a balloon pop in front of them, if they cry, or if you surprise them and they get upset, those are. And he followed them for 30 years. And he tested them 30 years later and then did an inventory scale on them to find out if they're introvert or extrovert, most likely introvert or most likely extrovert. And there's a correlation between the crybaby reaction to excessive stimulus at an infant age, I mean days old or months old, and introverted behavior later. Isn't that fascinating? It's called data mining. It's when you collect a whole bunch of data and then you see what lines up down the road. I wish we had time for it in this course because it's fascinating stuff. It's when you discover things like Moneyball, in the movie Moneyball, how that one guy for the Oakland Athletics, the manager, figured out, you know what, the best way to pick players is to look at the percentage of time they bring in runs when there's 2 men on. That's the best indicator. It doesn't seem to make sense. You'd think that, how about the guy that has the best slugging percentage? Or the guy that gets walked the most? No, none of that matters as much as getting runs in with 2 men on base. That's better tied to overall performance. And that's what's interesting about things like data mining. So, the problem with that, of course, you wait 30 years to collect data. You can lose people for all kinds of reasons. They get bored, they die. I mean, people die within 30 years. So yeah, there's a problem. Good. Anything else that comes to mind?
Oh, I was just gonna ask, would they just set like a parameter instead of like asking each individual kid what they're eating, just saying, okay, we need X kids of this age that are eating this for their diet?
You're describing what's called statistical power, which is very, very interesting. I hope we have time to get to it today. If not today, Monday, promise. You guys have often asked me, how big a sample do you need? How big a sample do you need? how big a sample do you need? It's a loaded question. You'd think that more is better. And in general, if you can get more good data, more is better than less.
So if we get more bad data.
Well, then you just put your hands up. No, but assuming you get good data, the question is, what's the benchmark? How many do you need? And there's an idea in statistics called power. And power is the opposite, in some ways, of what's called confidence, as we've talked about. We're talking about confidence. And I've often talked about how there's two kinds of ways of being wrong in statistics: false positive, false negative. Confidence is related to false positives. Power is related to false negatives. And they both should be discussed. We're going to discuss them today. That's part of the problem, is getting into today and looking at the ways to be wrong in a conclusion. Because you can finish a study and say, studies show diet may trigger adverse behavior in children. Somebody somewhere crunched the numbers on this somehow. I'm not exactly sure how. I didn't back check this one. And they concluded that, yes, if we have dietary changes, we're going to have behavioral changes. That's a positive test result. It's a positive test result, meaning we have concluded there is a difference. We could be wrong, correct? We could be wrong. That'd be called a false positive. That's a false positive. That's tied to confidence. So if you want to minimize false positive rates, you want to maximize confidence. We'll see why that is momentarily. We'll get to that today. But the ones you don't often read about in the headlines are the negative test results. You know what? We did a study, and it turns out no matter what you eat, behavior is behavior. I'm not saying that's true. I'm saying that would be a negative test result. We did a bunch of studies on diet, and you know what? Eat whatever you want. Eat that bag of gummy bears. Go for it. Drink that Mountain Dew after your Adderall. Doesn't matter. Doesn't matter at all. That would be a negative test result. And you could also be wrong with that, couldn't you? Your test could come back saying there's no difference, when in fact there is. And then you have to ask yourself, which kind of error is worse? That's part of the remainder of this class. And I'm not saying there's going to be one correct answer for everybody. Some people who are tied to certain ideas are going to think that a false positive would be worse than a false negative. And that's why I want to stimulate the conversation in this class. Because, Lauren, you brought the number 30 yesterday. The number, sample size 30, boom. It's this handed down number that's been handed down over years and years and years. Much like the number 95% for confidence. It's in all your papers you're going to read. P is less than 5%, 95% confident. 95%. Why? Why? I mentioned to you before, it's the old faithful of confidences, in that it minimizes both types of error on average. You could argue that's not necessarily true under certain conditions. The real reason is, it's been handed down to us, and it's what's in the papers now. Sometimes you don't want, go ahead.
What about the no hypothesis though?
That's all part of the day too. Give me time. You guys are asking, it sounds like you guys have all seen this kind of stuff before in bits and pieces. Fantastic. What I'm hopefully going to do is firm it up a little bit with this little bit in here, and you're going to start seeing some of the myths that exist around it. Because statistics is so often misused. It's so often misused. We've already seen one of the myths that you've seen in the news is the difference between statistical significance and practical significance. And here's what I mean by that. Let's make up some parameters for this study. When I say parameters, I just mean pieces of the study. Suppose this study involved 40,000 kids whose diets were monitored and 40,000 kids whose diets weren't. That's a lot of damn kids. And let's suppose the data was all legit, okay? There might be a 0.1% difference in whatever measurement we made between the kids who altered their diet and the kids who didn't. Maybe it's only 0.1%, right? Which is tiny, yes, tiny. But since the sample size is so large, those confidence intervals essentially shrink down to nothing, and they're not touching anymore. Which means the fishies in one tank can't get to the fishies in the tank, which means there is a difference at 95% confidence between the two diet and not diet group. That's statistical significance, yes? Is it practically significant? Probably not, right? Probably not. If you can guarantee that your child's going to become 0.1% more cognizant on a scale, that doesn't mean anything. And that's one of the problems with a headline like this. You've got to read more deeply to actually look at the results, to see what the difference is and if it's meaningful. This is why I gave you guys, this is why on your exam for next week, you do a confidence interval on I want to say it's a heart diabetes drug. I forget what it is now. It's the first problem on your exam is a diabetes drug confidence interval. Trying to look at a control group, experimental group, and see if there's a difference in whatever you're testing, and I forgot what it is now. The next question has you go back, look at the study again, and test the effect size, which is, okay, if it actually is different, how much different? That's the important thing in a lot of ways that most stat textbooks ignore it. They say, oh, significantly higher. statistically significantly higher? Is it practically significantly higher? And I told you in this class, I want to ignore that for the most part, because for the most part, we're just focusing on the techniques of the tests themselves. But it's always good to go back and train you to think like Americans and not just statisticians. And I mean well-informed Americans. Okay, study finds people who multitask are often bad at it. Okay, all right, fair enough. I have a hard time believing that because the only person that I see on a regular basis multitasking is my wife, and she's phenomenal at it. I mean, I've seen her like play with my son with one hand, check Craigslist for stuff with the other hand, and watching TV, and somehow doing it all, I guess. Maybe she's not. Maybe I think she's doing it all, and she's actually doing none of it well. Max seems to be enjoying himself, but he's 6. I mean, maybe when he's 8, he'll be like, Mom, pay more attention to me, please. Sorry, babe, if you're watching this. But the idea was, this was a study done at Stanford a few years ago. You'll actually see the data from this one in your homework for this section if you go in there and look at the homework. And I love it because what they did was they broke people into groups. Control group. Light media multitaskers and heavy media multitaskers. Okay? And they let them all do their thing. And while they were doing their thing, and when I say their thing, heavy media multitasking, light media multitasking, and no media multitasking, they gave them an assessment while they were doing their thing. And they compared the numbers, and it turns out that the ones that were media multitaskers, first of all, weren't multitasking properly. I think they were measuring like number of wrong keystrokes in a text message. But they also weren't getting the assessments right. Okay? Interesting? Maybe. What are any concerns with that study I just described to you? Renee, go!
How do you define your
How do you define a light versus heavy media multitasker? Always ask that question, please. Wait, how'd you break that down? How did you define that? You brought it up earlier, Kate, with the diet thing. How do you define a poor diet? Right? How do you define those things? Sometimes it's the definition itself that creates the difference. Just by how we talk about the autism, right? We'll come back to that one. I've got some new data on that. Kate, go!
That, and it says people who multitask are often bad at it. And use of the study was on media multitasking. However, that doesn't talk about a housewife or somebody at home who's making breakfast, getting the kids ready, checking their homework, and doing the different things rather than texting.
Like mom tasking,
yeah,
which is a miracle to watch. Yes, exactly.
The fact that they get dressed and walk out the door and on time to work, I say that they're awesome at it.
Dude, I say they're gods. God says, I guess. But the fact of the matter is, this was focused on only medium. But is that in the headline?
No.
Is that in the headline? No, of course not, because the headline, for whatever reason, has to grab your attention and suck you in. It's your job to go deeper and actually look at it. Check it out. I've got everything in your homework. I actually pulled this study and put it.
Watching TV.
Check it out. Read.
Okay.
They have a definition. It's the amount. Basically, it's the amount they do it in. It was their quantitative definition there by the amount of time they're spent doing it per day.
It's in the homework, you said?
It's in the homework for this one, yeah. Here we go.
What?
Go ahead, read that.
Sorry not to trust Harvard.
You like the first one. It's not so much Harvard, it's the use of statistics. Right, it's the use of statistics that is being, again, so, JC, go, please.
So you should just question it, not that you don't trust them. You have to look into it.
Did you hear that? You should just go.